Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of Git submodules and merges. Specifically, we'll unpack the complexities of merging branches that involve changes to submodules. It's a surprisingly nuanced topic, even for seasoned Git users. Get ready!
I'm all ears. I've definitely wrestled with submodule merges before. The documentation can be sparse, to say the least. So what's the core problem we're tackling?
Exactly. The core issue is predicting the outcome of a Git merge when a submodule's version differs across branches. Imagine you have a main branch and a feature branch, both referencing a submodule. You update the submodule in your feature branch, then try to merge it into main. Will the merge keep your updated version, the main branch's version, or something else entirely? The answer isn't always straightforward.
Oh, right. It depends on whether it's a fast-forward merge or a true merge, doesn't it? And the merge strategy used.
Precisely. A fast-forward merge is simple. If the feature branch is a direct descendant of main, Git just moves the main branch pointer forward. But a true merge, especially with the ORT strategy, default in newer Git versions, involves a three-way merge algorithm. This algorithm compares the submodule commits in 3 points: the feature branch, the main branch, and their best common ancestor. It's a bit like a sophisticated version control Venn diagram.
I see. So the three-way merge compares the submodule commit hashes, not the entire submodule content, right? That's more efficient.
Absolutely. It's all about those SHO1 hashes. If the hashes match in the feature and main branches, the merge keeps that version. If they differ, and one matches the ancestor, the other version is chosen. But if all three are different, conflict!
And that's where things get messy. What happens then? Does Git automatically try to resolve it?
Git attempts an automatic resolution. If one submodule commit is a descendant of the other, it performs a fast forward within the submodule itself. It's clever, but not always foolproof. If no such descendant relationship exists, you're left with a submodule conflict that needs manual intervention.
Interesting. So even if a fast forward is possible locally, GitHub or GitLab might still flag a conflict, right? Because they use libgit2, which doesn't handle submodule fast forwards in the same way?
Exactly. That's a crucial point. libgit2, used by GitHub and GitLab, doesn't proactively resolve submodule conflicts like the Git command line does. So even if your local merge works flawlessly, the remote merge might fail. This is why you often need to merge the main branch into your feature branch locally before pushing, to preemptively resolve potential conflicts.
That's a really important workflow tip. Though to summarize, understanding Git submodule merges requires grasping the three-way merge algorithm, the difference between fast-forward and true merges, and the limitations of libgit2 on platforms like GitHub and GitLab. It's a lot to keep in mind.
It is. But once you understand the underlying mechanics, you can anticipate and effectively manage these situations. Remember the key steps. Understand the three-way merge logic, check for descendant relationships between submodule commits, and be aware of the differences between local and remote merge behaviors. Mastering this will significantly improve your Git workflow, especially in complex projects.
Absolutely. Thanks for breaking it down so clearly. This has been a really helpful explanation.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you found this deep dive into Git submodules enlightening. Until next time, happy coding.
Bye-bye.